Well, hello again everybody. Well, as you can see, I've got a television on the bench again, which is a Murphy type V350. So this is classed as being a portable television. I think it's about 14 inch. So this television was manufactured in 1958 and I've certainly got no idea the last time it was used. Certainly it's been in storage by myself for at least 3 years, maybe even a little bit longer. So I think before we actually try to put power on it, we're going to have a go at just checking this rather large Jubilee electrolytic capacitor here, because I'm suspecting that it probably needs some reforming. Now this television set itself is actually just packed with waxy capacitors. In fact, you can see one of the waxy capacitors here, and I'm just suspecting, looking at this one here, I suspect that's the across the main. So we'll probably have to go ahead and snip that out. I could be wrong, but it looks as though it could go up to the mains, up to the mains input there onto these dropper resistors. So we'll have to take a look at that. But I think the first thing we'll do is, well, shall we try to reform that capacitor? Now normally the HT supply for this television would be derived from a Selenium Rectifier, and that's mounted underneath the chassis here, and we'll take a close look at that in a moment. But what's just caught my eye is I've spotted this diode here, which is a much more modern silicon diode. I say modern, it's still pretty old, and that's actually just tacked on top of what is it looks like some kind of two-stage choke arrangement here. So I think what somebody's done is they've actually disconnected the Selenium Rectifier. They've actually left it just dangling. They've left it in circuit but disconnected, and I think they've replaced it with this silicon diode. So I think what we'll do is, because the Selenium Rectifier, it's in the way of this electrolytic capacitor, so I think what we'll do is we'll just drop the Selenium Rectifier out first. I think this television is actually a little bit lighter than the was it a Stella? Sorry, it was a Stella I was working on last time. I think it's a little bit lighter than the Stella television, but it's still not what I would call lightweight. So here is a Selenium Rectifier. Now, as I said, I don't actually think this is still in circuit. I can see it's got a wire on it, but I don't think that wire actually goes anywhere. But if I actually take the rectifier out, if I just remove this from circuit, I think it's going to give us better access to the underside of the what looks like the main smoothing capacitor. So let's go ahead and pull that out. So I've got a variety of spanners and things which don't actually fit anything, so I'm just going to go through my spanner collection until I find one that doesn't fit quite as well as the rest. In fact, that looks like the fella. Are these nuts really different sizes? Well, they seem to be. Well, obviously this is going about as well as expected. Wow, this thing really is shoehorned in here. Can I actually even get the thing out? Wow, that was certainly a tight fit. Well, anyway, as you can see, I didn't actually have to unsolder anything from this Selenium Rectifier. It had actually already been undone, unsoldered by the previous owner and replaced with a silicon diode. Now you can actually see the way that these are made up. So back in the day you couldn't actually have a rectifier that would rectify a few hundred volts. They weren't able to manufacture diodes that were that good. You could actually only rectify a maximum of about 40 volts before the, I guess you would call it the junction, before the junction of the rectifier would break down under the peak reverse voltage. So the reason that these are like this with all the fins down it is, well, they need to be kept cool because they've got a relatively high forward resistance, so they do dissipate current. But what you've actually got here, you've got a number of transistor diode junctions, so you haven't got just one diode here. You've actually probably got several diodes which are all sandwiched together to create the to create a high enough peak reverse voltage. So the peak reverse voltage would be the peak mains plus on top of that whatever happens to be on the stored on top of the smoothing capacitor any time. So it's probably somewhere around 500 volts, maybe even a little more. So now we've got that Selenium Rectifier out the way, we can certainly see a bit more, and what I'm looking at is the main smoothing capacitor here. So it looks as though this capacitor's got two sections. It's got a red section and a yellow section. So if I just look at the label on the capacitor, it says that the red section should be 150 microfarad and the yellow section should be 200 microfarads, and I think those are both at about 350 volts. So I'm going to take my Esr meter now and let's just see if we can get a connection on there. Let's go for the yellow one first. A bit hard to get my hand in. I think I've just about got that. Okay, so that's coming up as 335 microfarads at 0.035 ohms, so it's not too bad on Esr, but it's certainly high on capacitance. Let's just try the other section. Okay, so the other section of the capacitor is coming up very similar as 344 microfarads. Now obviously electrolytic capacitors do go high in value as they get old and the electrolyte dries out, but I don't think that's what we're seeing here. The way that this capacitor is connected in circuit, it's actually a CLC smoothing arrangement. So what you've got here, you've got two sections of the capacitor and they're effectively being wired together in parallel by the inductor because it uses a CLC smoothing arrangement. So I suspect that what this meter's showing, it's actually trying to measure both sections at once and getting it a little bit wrong. So we don't really trust that reading, but that's okay. Now while we've got this television in this orientation, we can see again it's absolutely stuffed with waxy capacitors. Now strangely enough they were pretty much all plastic capacitors in my in that Stellar television that I looked at previously. I think they were all much more modern capacitors than this. There was a number of ceramic discs and you know, plastic polymer capacitors, whereas this one I think is a slightly more modern television, but it's using an early style of waxy capacitors. Now I can't see that any of the capacitors look particularly burnt or in an awful state. They don't look too bad at this stage. Some of them look a little bit melty, but that's probably because a television set itself does tend to run quite hot inside. That's probably fairly normal, but you can bet your bottom dollar that, again, you know, it's old equipment, waxy capacitors, they will have gone leaky. Whether they've gone leaky enough to stop it working, who can tell? I don't know. So here's my go-to high voltage power supply, which is a Heath kit. So we're going to connect up our high voltage power supply via a series current limiting resistor. The actual value isn't too important really, probably anything between about 10 kilo ohm and maybe 30 kilo ohm. I'm just happen to be using a 10 kilo ohm resistor because that's what I found floating about on the bench. Okay, just tack that on, hopefully that won't go anywhere. Now I don't think it's going to make any difference which side of the capacitor segments we actually put the power onto, because they're effectively connected together via the choke, so assuming that the choke's intact, that should be okay. And I'm actually going to use the chassis of the television, because I'm fairly sure that this capacitor, the ground connection, is chassis grounded, so we'll use the chassis. Now I do also want to monitor the rate at which the voltage comes up on this capacitor, because hopefully it shouldn't be drawing too much current. So to monitor the voltage drop across the resistor, I'm going to use a voltmeter, so I'm just clipping that lead on now. And again, the other lead now needs to go to the chassis. Okay, let's go ahead and juice this thing up now. So we've got about 100 volts now across that capacitor, well, on the dropper resistor, and hopefully you can see here the voltage is starting to rise. It's at 30 volts, 31. It's actually creeping up, so we're actually charging up this capacitor quite slowly. Now, you actually want that current limiting resistor, because if you try to charge up these capacitors too quickly, you can actually punch through the oxide layer on them and you'll cause a short circuit, because what we're actually doing is reforming, well, we're actually reforming the insulating oxide layer on the capacitor now. So that's the purpose of reforming these capacitors. Now, I'm not a big fan in reforming capacitors. Quite often it doesn't actually work. It all really depends on whether or not the capacitor is still wet inside. If the capacitor is still wet with electrolyte, you can probably reform them, but a lot of capacitors, the seals have gone on them, and if the seal has gone, they won't reform. So just looking at this capacitor, I can actually see a little bit of a dimple at the top of it. So it does look to me as though it has gassed off at some point. So it looks to me like the seal's broken. So we'll just have to see how we get on with this capacitor. Okay, so I'm just going to leave this reforming now for an hour or so, and we'll see what this voltage rises to. The power supply is set to about 100 volts at the moment, although I don't expect it to actually reach 100 volts. Hopefully it might reach about 80 if we're lucky, so let's leave that to reform and I'll bring you back in an hour. Now actually the correct way to actually reform one of these capacitors is to take it out of circuit, and if you're going to do it in circuit you should really go ahead and pull all the valves from the receiver, the television or the radio. Now you can notice that I haven't gone ahead and done that, and I haven't done that on purpose, because I know there's always some people out there who like to complain about things like cathodic poisoning, so I've purposely done it this way to give you something to moan about. So go on boys, knock yourself out. Okay, so it's about an hour and a half later and we've had these capacitors reforming, so we've turned up the power supply and we're at about, I don't know, just over 200 volts. We've got 216 volts on the meter here. Now I've gone ahead and I've took out that series resistor, so we're now actually directly applying our 216 volts to the capacitor. And as for the current that the set's drawing, it's probably drawing about, I don't know, that looks as though it's drawing about 18 milliamps. I'm not exactly sure what it should be, but certainly it's not a short circuit. Now a little test that I like to do is, let's just switch off the power supply and unplug it. Now you can see that the voltage here, it's falling, but it's not actually just falling like a stone, it's going down relatively slowly, so that's a good sign. That means that these capacitors, these bulk smoothing capacitors, have actually stored some charge. Now if these capacitors had been open circuit, this would have just dropped to 0 volts pretty much instantly, but the fact that it's actually going down slowly is quite a good sign. Same thing is if we actually switch the power supply back on again, we'll find that the current meter will bang over hard. It will shoot up as these capacitors charge up and then it'll drop again. So let me just do that. See that? It went hard over and then it dropped back down when those capacitors had charged up. I'm just going to let these capacitors discharge, and then what I'm going to do is I'm going to put my hand inside this television and I'm just going to touch all the various components. I'm going to run my hand over everything once this voltage has dropped to a safe level, and I just want to see if any of these capacitors are warm. Now of course many of these capacitors will have more than 200 volts on when the television is actually running, because there's probably a boosted line here running at, I don't know, 500 volts or more, but it's still not a bad sign. If you know, if there's any capacitors getting hot at 200 volts, they're certainly going to get hot and burn out at 500. So I don't think this is a bad thing to do. Okay, so the voltage on this set now has dropped to about 15 volts and falling. So it should be quite safe for me to put my hand inside now. So I'm basically just going to have a feel round. Any waxy capacitors or electrolytic ones that I can see, I'm just going to put my hands on them. Not forgetting to check the main smoothing condenser itself, which is completely cold, so that's a good sign. Well, I'm going to take that as a good sign because everything I've put my hand on is cold so far. So I think on that basis I'm probably ready to try to put some 230 volts on this, which is always a worrying time, but at the end of the day at some point you've got to put some power on this. Now of course some people might choose to go ahead and swap out all those capacitors first, because these waxy ones probably are bad. Again, I'm thinking the reason I'm not swapping them out first is because for all I know the line output transformer on this television is burnt out. It could be totally damaged, so I don't want to spend too much time recapping things if this television has got absolutely no signs of life. So I'm going to put some power on it, and yes, it is a risk because something could short out, and maybe if I changed out some of those capacitors I'd probably get rid of that risk, but no, I don't want to change out all the capacitors, spend all that time and money and find out that this television is totally no good. There is one capacitor that I've got to change, which is that capacitor, the one that's across the mains. So let's go ahead and find if there is one, and if there is, let's cut that out. Well, I'm afraid everybody knows that's going to be bad, isn't it? Hello, Mr. Across the Mains capacitor. Meet Mr. Snippy. Snippy, snip, snip. So here's the mains plug, and we've got to remember to put this on the right way around because, as we spoke about earlier, this has actually got a live chassis on it, so we've got to make sure that the neutral side of the connector goes to the chassis, otherwise the chassis will very easily become live. But it's actually quite interesting that this is a crusty old lead that came with it, and of course I was expecting it to be a 2-pin connector, but it's actually got an earth lead on it here, so you can actually see we've got the old British wire colour codes here. We've got black, red and green being earthed, but yeah, it's a 3-pole connector, so this does have provision for earthing on it, but the set itself doesn't have provision for an earth. There's an earth connection here, a metal strip on the back of the plug, so that's the earth, but there's nothing to pick up the earth on the television. But looking at it, there is kind of a cutout in the plastic that looks as though maybe some other sets did have an earth. So we're just going to find out which is actually the neutral side of this connector, because that's the side we've got to keep on. So let's just put a clip on our chassis. Put another clip. Okay, so that's beeping intermittently, so that isn't the neutral connection I've got, so it does go that way up. So we've got to remember to put the plug that way up. What I might do is put a bit of tape on it or something to just mark that. In fact, I think I can just write an N on there. N. Hopefully that will be enough to remind me. I think we'll make the assumption that this diode that's bodged in here will do, although really it probably should have a series resistor in, because if you replace a selenium rectifier with a normal diode, the forward drop of a normal diode is much lower than a Selenium Rectifier, so it probably would have had or it should have another series resistor installed, because Selenium Rectifiers are a bit softer than the modern silicon equivalent. But this is what it's got in, so we'll leave that in for now and swap it out later. Now this power lead is actually looking pretty crusty, but I'm hoping it's just going to get through the testing phase. I'm not going to put a plug on it at this point. I think what we'll do is we'll just connect it via my old quick block. I don't know why I'm bothering to buy the earth there, given that it's not actually connected to anything. Now really, if I cared more about this television, I would go ahead and I'd change out some of the capacitors, probably the ones that are bypassing the filaments on the valve heaters, because if one of those gets short circuit, it can put undue high voltage onto the filaments, which can cause filament damage, which ideally we would want to avoid. And I'm guessing that this television also has a boosted line somewhere, so that capacitor gets highly stressed. It's probably got 500 volts on it, so again, in a perfect world we would change that out. But I think what I'm tempted to do, rightly or wrongly, I'm tempted just to put some power on and see if we get any signs of life or not, because that'll make me decide whether or not I want to do any more work on this television. And I think I'm going to muster all the creature comforts I can, in that I'm going to use both the lamp limiter and also this variac transformer to run it up. And I'll also be plugged into my isolation transformer, which is a little bit safer for these live chassis. So I think initially we are going to have a go using a lamp limiter, although lamp limiters, I don't think they work so well for testing televisions. It's probably a matter of getting the right wattage. But also televisions don't like running at a lower voltage. If you run the television at too low a voltage, the line output oscillator won't start up, and if that doesn't start up, it means that there will be too much current going through the I guess the line output valve, and it will probably red plate. So it doesn't seem like a good idea to dally around at too low a voltage, but I think I would like to just initially still have some circuit protection in place. Also going to plug in my watt meter, although again the watt meter doesn't seem to work so well when it's run off the variac. It doesn't tend to start up properly. Okay, that's 230 volts on the set, and I can see some valves glowing, so we have got some power on there. But I can't hear any noise, and I can't hear a line output transformer oscillating. Got a bit of a negative result there. I'm wondering if we've got any HT. Certainly I could see some of the filaments glowing on the valves. Let's see if we are developing some high voltage. Okay, so the TV should have enough HT on it to operate now. We've actually got about 200 and yep, can't hear any line output transformer action there. Right, well we can see that the HT volt's dropping now that the valves are heating up, which is kind of normal. I'm wondering if we should just risk taking the lamp limiter out of circuit and giving it a blast. I am actually quite tempted to try that. Right, I think I might be able to hear a bit of a buzz now, but I might be imagining it. I'm not dead sure. I think I can hear a high-pitched whine. Have we got any HT? That's the question. Okay, I'm going to turn off and I'm going to get my HT meter. Okay, so I've got my high voltage meter resting on top of the anode connection to the television tube, and I'm going to switch on again. Let's see if anything happens. Okay, so we've got 10,000 volts of HT at the moment, so that's a sign, and I can now hear the line output transformer running. Oh, and we have got a very faint line, so it looks like we've got some horizontal action, but we've got no vertical. So it looks like we've got a frame collapse at the moment. So we've got nothing coming out of the speaker on this, but having just thought about that, I don't even know where the speaker is on this set. I haven't actually spotted a speaker, so maybe we'll go and find where that speaker is. But certainly we've got a little bit of life there, haven't we? I think we'll quit while we're ahead and we'll just turn that back down again. Okay, well I've just found the missing speaker. The actual missing speaker is actually still inside the cabinet, so explain that to me if you can. So I wonder where the contacts are for this speaker. I think we're going to just solder some wires on and try and extend them, but yeah, I didn't expect that. Don't know if you can see inside the enclosure here, but at each side of the speaker there's some big sprung contacts, so these must make contact with something or other. Question is, what do they make contact with? So we've got a couple of little studs sticking out from the back of the chassis here. One of them has got this insulation pad round it, so I'm guessing that these two studs here, these must press against the speaker contacts. It's funny, I completely forgot about the speaker. So yeah, let's see if we get some hum. Let's find a way of connecting that speaker up, which it is. So one of the speaker wires is chassis ground, and the other one is must be one of these. 0.2 ohms. It's probably that one, isn't it? Saying that, there's not a huge amount of difference in these. I wonder what colour the wire is. I think it's a brown colour. Can we trace the wire through? Well, I've gone ahead and I've made up a pair of long clip lead wires, and just going to clip that onto the speaker. Now I can put that down there out of the way. I think that should be okay there. So in theory, when we switch on this time, we should actually maybe get some hiss out of the speaker. Let's find out. It does seem like this television takes a fair while to actually warm up. Well, still can't hear it. Oh, there's a little bit of hiss there. Okay, well there's a little bit of hiss there. I wonder if we should try the signal generator at this point. I wonder if it'll be possible to feed in a signal from my standard converter. I think I'll give that a try, see what sort of picture it makes, if it makes any picture at all. Well, I do believe it is trying to make a picture there. Just going to turn the brightness down a bit because I'm not sure at what point we'll start to get some screen burn. Now, it's not going to prove anything, but I think I'd like to try a video source onto it just to see what happens. Well, having got some good proof of life with this television, I don't think I want to go ahead and run it for very much longer because we could be doing some damage. So the line output, or horizontal, actually looks pretty good to me, but as you can see, the actual vertical, the frame has partially collapsed. Now that's almost certainly due to a number of failing waxy capacitors, which are probably in things like the frame oscillator stage, the frame output, and maybe with the linearity control. So we've got to go ahead and start changing out some of those waxy capacitors, and of course not forgetting probably one of the first capacitors that we also need to change out is the one on the boosted line. So I'm going to go away and start changing out those capacitors, and maybe I'll bring you back next time to see what progress we've made. But until then, as always, thanks very much for watching, and bye bye for now. Bye bye.